Welcome viewers. Our topic is determining similarity. So we are going to look at whether two or more triangles are similar or not. And starting with the question, triangles ABC and DEC are similar. And now why? Because we need to give the proof and some of the properties attached to this to be able to make it clear that the two triangles are similar. Now, the figure below, we can be able to see two triangles that are similar. So we have ABC and triangle ECD. So those are two triangles which are similar. And now we need to show the reason. Now we can say that angle ACB is equal to angle ECD because these two angles are vertically opposite to each other. Again, angle ABC is equal to angle DEC. So these are just some of the reasons that makes these two triangles to be similar, because the corresponding angles are equal. So finally, we have that angle BAC is equal to angle EDC because the two angles are alternate to each other. So on the comparing the sides, because these two triangles ABC and DEC are similar, so we can have AB corresponding to DE, again BC corresponds to EC, and finally AC corresponds to DC. So you should maintain the order to be able to look at the pairs of sides of these corresponding lengths. So let's have an example so that we'll be able to see if we can use the previous concept on similarity and scale factor to be able to answer this. So if BC is parallel to DE, then explain why triangles ABC and ADE are similar. So we have, from the figure below, we have two triangles which are similar, and that is ABC and ADE. So from that, based on comparing their corresponding angles, we can say that angle BAC equal to angle DAE because that is the angle common to both triangles. Again, we have angle ABC equal to angle ADE because of the corresponding angles between the parallel lines. So finally, we have angle ACB and angle AED are equal because of the same reason. Corresponding angles are equal. So I think two or more triangles are similar if and only if the corresponding sides are equal and corresponding angles are equal. And so we are going to have, from a diagram, we can be able to draw a line, or rather make a line to cut the diagram maybe, or an original triangle, into two, so that we'll be able to show further if they are similar or not. So a line drawn parallel to any side of a triangle produces two similar triangles. For example, we have triangle ADE. If we draw a line BC, then that means that triangle EBC and EAD are similar. It is because of the corresponding angles being equal. And so, on the other side, we can also cut it BC so that we have two similar triangles, DBC and DAE, are equal as similar because of corresponding angles. Now, another question. So given that the two triangles below are similar, so find the distance y. So in this case, we are going to use the scale factor, and then we equate it to another set of the corresponding sides. Because from what you can see here, we have two triangles being similar. We have ABE and ACD. So if we compare the sides, then we have AE over AE and AD. So those are sides because the two triangles are similar, so we can compare their sides, because it is said that for two triangles to be similar, then their corresponding sides are equal, and the ratio of their corresponding sides are equal, and their corresponding angles are also equal. So it should be the ratio. So the ratio of their corresponding sides will give us the scale factor, or rather how many times it has been enlarged to get that bigger triangle. So we are going to get a reduction scale factor because we are reducing the biggest triangle to the smallest triangle. And so comparing their sides, the ratio of their sides, so we have AE over AD. That will give you 5 over 50, and that will give you a ratio of 1 over 10. So you equate that ratio to another set of corresponding sides, and that is y over 20. So you get the value of y, and you get it is 2 centimeters. Alternatively, you can use another approach to find for the distance y. So we are going to reason on the fact that the smallest triangle ABE has been enlarged to the biggest triangle ACD, and so we use enlargement scale factor. So we compare the ratio of we compare the sides, so we shall get the ratio of the corresponding sides, that is AD over AE, that is 50 over 5, and you get that to be 10. So equate that 10 to another set of corresponding side to get the ratio. So it's going to be 10 equated to 20 over y. So the value of y there is 2 centimeters. Okay, in another example, in the diagram below, BE is parallel to CD, and all measurements are as shown below. Now, the question part A, calculate the length CD, and part B, calculate the perimeter of the trapezium EBCD. Now, from the figure, we realize that there are two triangles which are similar. We have ABE and ACD. So we are answering on part A. We have to relate on the scale factor so that to be able to find for the unknown length. So let's find the scale factor. That is the ratio of the corresponding sides, 10, and 6, because it is, you can see that AD and AE are corresponding to each other. So it means if we can get their ratio, then it will be 10/6 equal to another set of corresponding sides, and that is the length that we want, CD, and the other one corresponding to BE, that is 4.8, so that we be left with the unknown length, that is CD, being 8 centimeters. So CD in both cases is 8 centimeters. Now, turning to part B, we will use the same scale factor, that is 10/6. You can as well simplify it. So 10/6 is equated to another set of corresponding side, and that is AC, and 4.5. So because we want, that is the side that is missing, we want to get, for us to be able to get to calculate the perimeter, then we need to have the length BC, so that we add all the sides. So we'll say we want to find AC first, and then we subtract AB, so that we see what we are left with. So AC is equal to 7.5 if you do cross multiplication. So if AC is 7.5 and AB 4.5, then probably we have BC as 3 centimeters. And now the perimeter, because perimeter is the distance all around a given figure. Now the trapezium EBCD, it is enclosed by a length of 19.8 centimeters. So you add 3 plus 8 plus 4 plus 4.8 to get the perimeter. Okay, in a pair of similar triangles, the ratio of the corresponding sides is constant, always producing the same enlargement or reduction. And now, using that statement, we can now work out the value of x in the question below. Find the value of x given that the triangles are similar. So, true, we can see AEB and ADC, to be similar. Therefore, corresponding sides are also equal, or rather are in proportion. So by comparing their ratio, we have AB and AC. So we equate it to EB and DC. So we can see EB and DC. And so we substitute, we have AB as 3, AC as 3 plus X, because it is the whole length, equated to EB, which is 4, over DC, which is 6. So with that, we can simplify and find for the unknown value X. So the value of X is 1.5 or 3/2, and that is the length of BC. Now, in our last example, find the value of X given that the triangles are similar, and as you can see, we have PQR similar to SRT. So we are going to do the same. We put the sides in the ratio. So we are going to have PQ and ST corresponding. And so in ratio form, we have PQ over ST equal to PR over PT